So, good evening, one and all. I am Dr. Sai Prakash Chidrala, and my paper ID is 335, and my paper title is A Novel Method to Detect and Classify High Impedance Fault in EV Integrated Distribution System. And I am from SR University, Warangal, Telangana. And these are my contents. So coming to power system faults. So power system faults refers to any inconvenience that occurs within the system which cause power interruptions, damage to equipment, and even pose a risk to public safety. Sometimes power system faults can occur at any point within the system, starting from generation, transmission, and distribution system due to various unavoidable system situations like when an object come in contact with overhead conductors and extreme weather conditions like heavy wind, rain, and heavy snow, and sometimes human errors. These effect of faults results in imbalance in the power system, which can cause abnormal change in voltage and current in the system. So as the fault may occur in any form, so identification of fault is important task. So which can be easily done through classification of tasks. So now we have to know about what is the classification of. So the power system faults can be classified into two types. So one is short circuit fault, another one is open circuit fault. So when an electrical circuit breaks, causes in power interruption, preventing current flow and damage to equipment. So these types of faults are called as open circuit faults, and there are three types of open circuit faults like single phase open circuit fault, two phase open circuit fault, and three phase open circuit fault. So coming to the short circuit faults, so it occurs when a fault current flows directly between two conductors bypassing the load. So this can cause a significant increase in current, leading to overheating and damage to the equipment. So there is another special type of fault. So when the open conductor get connected with high impedance surface, or the short circuit happen through a high impedance surface, then it is called as high impedance fault. So this one is a very peculiar fault which we have to address as soon as possible. So detection of high impedance faults using traditional protection devices like overcurrent relays and distance relay is difficult because the fault current is usually smaller than the load current. So the main arcing is a prominent phenomena in high impedance fault. So when an arc ignition occurs when the magnitude of voltage is higher than the air gap breakdown voltage. So there are some characteristics of high impedance faults. They are like asymmetry, sometimes intermittence and waveform distortions, and non-linearity in the sine waveform, and sometimes build up and shoulder. So these are the characteristics of high impedance fault. So there are various modeling approaches are there to model the high impedance fault in simulations. So they are like including analytical models, numerical models, and also hybrid techniques. So one of the important model is Emmanuel high impedance fault model. So this Emmanuel devised an HF model, which is uh, which is based on actual observations and theoretical components. So these asymmetric fault currents flowing through the system are represented by the uneven resistance that are present. From figure 2, we can see the uneven resistance are there. So these resistance of faults are denoted by the symbol Rp and Rn. The fact that these two resistance have been values that are not equal enable asymmetric faults current to be generated. So these two resistance will form asymmetric characteristics of the high impedance fault. The figure 2 represents the modified Emmanuel HF model. So uh, coming to literature review, there is a one paper early identification of short circuit fault in grid connected AC microgrid in the journal ITB Transition of Smart Grid. The majorly they have done some PSCAD EMTDC simulations based on the short circuit failure in low voltage AC microgrid by using some wavelet energy spectrum for detecting the short circuit faults in the microgrids. But there is some demerit in this paper, like it only identify the symmetrical faults, and also it takes some fourth level of decomposition, which is very lengthy process, and very it consumes more time to locate the fault. Comparing to the coming to the um, literature paper review 2, the fault detection and localization of overhead line 11 kV distribution line with magnetic measurements. So in this paper, they took both short circuit faults and magnetic high impedance fault, and detected the fault detection as done by using magnetic field measurements. But the problem with this method is it should contain some MF sensing modules, like magnetic field sensing modules, on a specific distribution system, and again optimization will be uh, should be done for getting the for minimizing the cost. And coming to the another demerit of this paper is it uses the Biot-Savart's law and mathematical analysis to detect the local fault, which makes more uh, uh, which makes more complex to detect the fault in this process. So to avoid these things, to avoid the mathematical things, we proposed a method which is based on the feature extraction through the signal processing technique, and also recognizing the patterns to the SVM based classifiers. So the proposed method consists of, like, we measure the voltage and current measurements. We will have to obtain the value of voltage and current measurements at the measuring devices, and later these voltage and current signals are decomposed through the radial uh, discrete wavelet transform, and the future extraction will be done, and later those high frequency components are again fed to the SEM based classifier, and then we classify whether the fault is a low impedance fault, that means short circuit fault or open circuit fault, and also high impedance faults, and later the circuit breaker will be tripped. Then you can clearly see here in the figure 4, uh, and the weekly load demand plot and is simulated, and it is shown in, so weekly load and yearly load also shown in this particular, in the figure number 7. So we have up to decomposed up to 9 levels decomposition. So total 2000 frequency components are treated as data training data, so which are the high frequency component, which consists of the information regarding the uncertainty in the signal. So the scatter diagram of the fault classification is shown in figure number 8. So the scatter diagram is also shown in the figure number 8, and the table 1 gives the performance analysis of the HIF detection here. So we use a classify HCM, and we have to use a different kernels functions, like linear kernel function, Gaussian kernel function, polynomial kernel function, sigmoid kernel function, and RBF kernel function. So we can see here at particularly at a radial basis function, the detection accuracy is very high of 99.75%. We also introduced the noisy conditioner, like SNR equal 25 dB. Even though noisy condition, we got the high accuracy. And we also compared the proposed method with various methods that already existed in the literature. So our proposed method RADWT plus RBFSVM, the accuracy of detecting the fault is around 99.75. We also took the condition of both noisy and normal condition. The dependability of this method is 100%, and the DWT plus SVM is 99.34, and DWT plus DT is 98.22, and Stockwell transform plus ANN and is 99.15, and morphology gradient plus fuzzy logic classifier 99.40, and DFT plus ANFIS is around 99.64. And the main advantage of this method is we took both normal conditions and also noisy conditions, and the dependability is around 100% with accuracy with detection accuracy of around 19.99.7. So we concluding some um, conclusions from this research. So it is concluded that radial basis function kernel based SVM classifier is observed to be the best classifier to detect and classify impedance faults with around 99.75 classification accuracy and 100% dependability. So the proposed method is tested on real time IEEE European low voltage distribution system under normal and noisy conditions. It is concluded that proposed method is performed better for both 40 decibel conditions, SNR conditions, and also 25 dB SNR condition, which is noisy condition. So RADWT require more decomposition levels, which makes proposed method little sluggish, and it is considered to be the main drawback of this proposed method. So the proposed method also outperformed existed methods in literature in terms of classification accuracy and dependability, which is we have already seen in the table number 2. So these are the major references of my paper.